Wi-Fi. It's that invisible force that just powers our entire modern world, right? It connects us to work, to our friends, to our entertainment. But have you ever stopped to wonder how it actually works? Well, today, we're going to pull back the curtain on the incredible tech behind Wi-Fi. You know this logo. I mean, you probably look for it multiple times every single day. It's become this universal symbol for connection, a promise that you can get online. It's printed on literally billions of devices all over the globe, and for most of us, it's the key to our digital lives. And that's the thing, isn't it? We depend on it completely, but for most of us, it's a total mystery. You just connect, and it's there. So today, we're going to demystify it. We're going to look at the physics, the actual hardware, and the global rules that make it all possible. Okay, so first things first, let's get the biggest misconception about Wi-Fi out of the way right from the start, and it has to do with its name. It sounds plausible, doesn't it? You know, like hi-fi for high-fidelity audio, but the truth is, Wi-Fi doesn't actually stand for anything at all. It was just a catchy brand name cooked up by a marketing firm. Because, let's be honest, IEEE 802.11 doesn't exactly roll off the tongue. All right, so now that we've got the name straight, let's get into the really cool part, how the signal actually travels through the air. And spoiler alert, it's not magic, it's physics. See, Wi-Fi is just a type of radio wave. It's part of the exact same electromagnetic spectrum that includes everything from the visible light our eyes can see to microwaves and even X-rays. The only real difference between all of them is their frequency and their wavelength. Now, you've probably seen the two main Wi-Fi options in your settings, right? 2.4 and 5 gigahertz. Well, think of it like this. The 5 gigahertz band is kind of like a super fast sports car. It can carry a ton of data, but it's not great at going over speed bumps, you know, like walls. The 2.4 gigahertz band is more like a sturdy truck. It's slower for sure, but it can power through those obstacles much more easily. It's this fundamental trade-off between speed and range. So how does this wave move? A really great way to picture it is to think of your router as the epicenter of an earthquake. It sends out these radio waves in all directions, just like ripples spreading out in a pond. And just like those ripples, the signal gets weaker and weaker the further it gets from the source. There's actually a technical name for this weakening of the signal. It's called free space path loss. It's just a law of physics. The further the signal has to travel, the weaker it's going to get. It's exactly why your Wi-Fi is always the strongest when you're right next to the router. Distance is the #1 enemy of a strong Wi-Fi signal. Okay, so these invisible waves are all well and good, but they have to be created and understood by actual physical hardware. So let's take a look at the machines that do all the talking. And wow, have they evolved. On the left, that's an early Wi-Fi adapter for a laptop. This big, clunky card that stuck way out of the side. And on the right, that's a modern USB adapter. The technology has just gotten exponentially smaller, faster, and way more powerful over the years. In fact, it's gotten this small. This tiny little chip is an entire Wi-Fi radio. It's this incredible level of miniaturization that allows us to have Wi-Fi in pretty much everything: our smartwatches, our thermostats, even our light bulbs. And as the hardware got smaller, it also got much, much faster. I mean, in just over a decade, we've gone from Wi-Fi 4 all the way to Wi-Fi 6. Now, to put that into perspective, in the time it would have taken you to download a single song on Wi-Fi 4, you can now download an entire album or more on Wi-Fi 6. Each new generation has brought these huge leaps in speed and efficiency, letting more and more devices connect at once without everything grinding to a halt. So we've got the physics, we've got the hardware, but how does a Dell laptop talk to an Apple router? How does any of this stuff work together? Well, that's where the rule makers come in. These are the crucial, kind of unseen organizations that make sure every single Wi-Fi device in the world can speak the same language. First up, you've got the regulator. Here in the US, that's the FCC. You can think of them as the government of the airwaves. They're the ones who decide which frequencies are open for public use. This is the so-called unlicensed spectrum where Wi-Fi lives. And they set the rules for how powerful those signals are allowed to be. Next, we have the standard creator, the IEEE. This is this massive global organization of engineers, and they're the ones who literally write the technical rulebook for Wi-Fi. They create these incredibly detailed standards that manufacturers all over the world use as a blueprint to build their devices. And finally, there's the certifier, the Wi-Fi Alliance. And this brings us right back to that logo we all know. They're basically a group of companies that take the IEEE super technical standard and create a testing program.
If a product passes all their tests, it gets this stamp of approval, which guarantees it will play nice with every other certified device out there.
So let's put all these pieces together, shall we? We've got the waves, the machines, and the rule makers. How do they all combine to create that seamless experience that we all just take for granted every day? It really comes down to this simple but incredibly powerful process. The engineers at the IEEE write the blueprint. Companies all over the world build their products based on that same blueprint. And then the Wi-Fi Alliance tests everything to make sure they all follow the instructions correctly. It's really a beautiful system of global cooperation. And at the heart of it all is this mission from the IEEE. This isn't just about moving bits and bytes around. It's about a global community of engineers working together to build something that truly benefits all of us. When you think about it, it's an incredible achievement. So, the next time you see that little Wi-Fi symbol and you connect to a network, just remember, it isn't magic. It's the result of physics, decades of brilliant engineering, and an amazing system of global collaboration. It's already connected our computers and our phones, so the only real question is, what's it going to connect next?